Let's begin. Today's July 12th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 12, 17, 19, and 22. And the puzzle uses the green verification cards. And the code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and in the bottom row, we've got criteria card D, criteria card E, and criteria card F. So criteria card A looks at our first digit, the triangle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card B looks at the 3-digit solution and will let us know how many of those digits are 3. Should there be no 3s, a single 3, perhaps 2, maybe even all 3 are 3. Criteria card C will compare our first and last digit, our triangle and circle values, and in comparison, the Turing machine will let us know whether triangle should be less than circle, perhaps triangle is equal to circle, or maybe even triangle could be greater than circle. Criteria card D again looks at our 3-digit solution and will let us know how many of those digits are even. Are there 0 even, 1 even, 2 even, perhaps even all of them are even. Criteria card E look at the first and second digit, our triangle and square, add them together and compare that to 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will again take a look at our 3-digit solution and tell us a little bit about the order of the digits from triangle, square to circle. Should the digits come in an ascending order, meaning that they're increasing, as in the example 135, could they be descending or basically decreasing, as in the example 421, or could it be that they have no order, as in the example 231? Notice that in the no order situation that it goes from a small value to, it increases to 3, but then it then decreases down to 1. So that shift from increasing to decreasing, or similarly from decreasing to increasing, that's one way to define the code to have no order. And remember, the objective of today's puzzle is to find that one unique 3-digit solution that abides by all of the 6 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card A. I want to find out if that first digit is an even or an odd digit. So let's test A. Okay, so the Turing machine does not approve of what I have. Notice that I did choose an odd 3. The Turing machine is telling me, nope, it cannot be odd. So let me go ahead and type that up and state it as that triangle is an even digit. And because it is an even digit, that means I am going to cross out all of the odds. I'm going to cross out 1, 3, and 5. Okay, what's next? We do have a single even so far, so we know that there has to be at least 1 even. There could be 2, maybe even 3. Let's see. Let me go ahead and compare triangle and circle. So let's see what happens when I test criteria card C. Okay, so it does not approve of the proposal. Again, I have 314. I do have a triangle as 3 and a circle of 4. So obviously the Turing machine is telling me no, triangle cannot be less than circle. So what I'm going to phrase it as is that triangle should be either equal to circle or greater than circle. So let me go ahead and type that up for criteria card C, that triangle is either we'll say equal or greater than circle. Yeah, if triangle's supposed to be greater, yeah, I think circle can't be 5. It could be 4 because of the equals, but yeah, it can't be 5. Okay, what else? I think I'm going to test criteria card E to see a little bit about the sum of the first and last digit, or sorry, first and second digit. So let me go ahead and test criteria card E. Okay, so again, it does not approve of the proposal. Notice that I do have triangle 3, square 1. That sum is 4. So in fact, what it's telling me is that the sum should either be equal to 6 or greater than 6. So let me go ahead and type that up in section E. That triangle plus square should be either equal to or greater than 6. Okay, so for it to be equal to 6, notice that I do have triangle, an even triangle, so that means that it would have to be a switching of 2 and 4. They both have to be even. But if they were to be greater than, then I think it's more wide open. That said, I think we can cross out square as 1 because when I add either 2 or 4 to a 1, that sum is still less than 6. And I think that's it, because square 2 can be added to 4, 3 can be added to 4, and then 4 could be added to 2 or 4, and same thing. So I think that's the only thing I can cross out for square. Yeah. Yes. Okay. Well, that does it for this turn. We've already done our 3 Turing tests for this round. Now we're going into the phase of talking through how to construct a good second round proposal. So let's go ahead and take a look. We did not test how many 3s there are. Notice that there are only 2 3s left. We also didn't test how many evens there are. As mentioned, we know there's at least 1 even, and then there's also the criteria card telling us about the order of the digits. So like I mentioned, the only ways to get 6 for triangle and square is to add up 2 and 4, which would mean that we have 2 evens there. But, you know, potentially, again, it could be that there could be 3 evens if indeed triangle is equal to circle. Or even if it's not, it could just define the other even digit. But I think I think we can't have 3 evens, because if we know that there are 3 evens, then we know there's no 3 digit, right? Because if we have 3 evens, there are no odds, and therefore no 3s. So I think we can eliminate 3 evens and no even. So there's either 2 evens or a single even. Yeah, let's go with 452. Let's see what happens. Okay, so I think I will retest criteria card E to pinpoint the sum. So let me go ahead and retest E. Okay, so yes, it is true that the sum is greater than 6. So let me come over here and cross out the equal and or. So we know that the sum is greater than 6, which means that I can cross out the 2 for square. And I think that may be it, because 3 can be added to 4. Okay. Well, that really didn't cross out too many possibilities. I don't have a 3. So I guess let me go ahead and test criteria card B. Okay, so it does not approve of my proposal of having no 3s. So there's at least 1 or 2 3s. So there are 1 or 2 3s. And so, yeah, it could be square is 3 or circle is 3. Obviously, there can't be 3 of them because I do have an even. And let's go ahead and then test criteria card D to see how many evens there are. So that would be D. Okay, so that is also incorrect. Oh my goodness. So it is not true that there are 2. Now, because we know there's at least 1 3, there's at least 1 3, we know that there's either 1 or 2 evens. Is that right? Let me just type this up for criteria card D. There are, well, let's see. Yeah, there can't be 3 because, again, there's got to be at least 1 or 2 3s. And it didn't like the 2, so I think there are 2 odds. Is that right? Let me type this up. For D, there are, can't have 3 of them. Well, hold on. Yeah, it didn't like the fact that I have 0 3s. There can't be 3 3s. So there's either 1 or 2. Okay. And it didn't like the fact that I have 2 evens. There can't be 3. Yeah, so I think there are, I think we can safely say there is 1 even digit. It didn't like my 2. Can't be 3. Can't be 0. So it's got to be, yeah, 1 even. And possibly it could be a single 3 and then the other odd is forced. So that means that, okay, so if it's true then that there's only 1 even digit, that means that square cannot be 4 and circle can't be 2 or 4. Can't be 2 or 4. Okay, so what are we looking at? And I think at this point, maybe I can start listing them out. So we know the sum has to be greater. So that would be, if it's a 2, it would have to be 2, 5, and then a single 3. And that's the only one for 2. For 4, there are more. There's 4, 3, and it could be 4, 3, 3, or 4, 3, or 4, 3, 1, depending on the order, or 4, 5, 3, 4, 5, 3. Okay, so again, yeah, 2, 5, 3, 4, 3, 3, 4, 5, 3, and it can't be 4, 5, 1 because we know there has to be at least 1, 3. And I think that may be it. 2, 5, 3, 4, 3, 3, 4, 3, 1, and 4, 5, 3. Okay. So that means it has to be greater. So that means, yeah, we can eliminate 2, 5, 3. Yeah, and actually that's the one that failed, right? 3 is less than 4, so 2 is less than 3. Yeah, of course we can cross it out. Okay, so that's good. So now let's go back to 4, 5, 3, no order, descending. And technically 4, 3, 3 is also known as no order, but that no order has 2 3s and that has 1. So let's see, if we do go to a third round, which of those would be best to test? So I think A, we know for sure. We still don't know the number of 3s. I think we've already concluded that it can't be equal. So let me go ahead and cross this out. There's 1 even. Yeah, they all have a single even, and they all have a sum that's greater. So the only thing we have not really tested is criteria card F for the order. But we, like I said, this one and the last one have no order. Is there anything we can say about, oh, if it's descending, perhaps we can say, yeah, I think it cannot be descending, because if we knew it was descending, then obviously triangle is greater than circle. Regardless of what square might be, descending, you will always have triangle being greater than circle. So I think we can eliminate 4, 3, 1 because of that fact, because that would make this card irrelevant if we knew it was descending. Okay, so they both have no order. So yeah, so it just comes down to how many 3s. So let's go ahead, I'm going to test 4, 5, 3, and we'll know definitively whether there's 1 or 2 3s. So let's go ahead and do that, and we'll test B again. Okay, so it's true that there's only 1 3. So let's cross out the or 2. Okay, so it seems that the answer is indeed 4, 5, 3. And so let's go ahead and cross out the 3, 3, 4, 3, 3, since that has 2 of them. And so let's see, yes, triangle is even. There is only 1 3. Triangle is larger than circle. Yes, the first is greater than the last. There's 1 even, the 4. The sum is greater than 6. And I guess we are deducing no order. So let me go ahead and type that up here. that we're deducing no order. Okay, so let's go to turingmachine.info and verify that 453 is our solution. Okay, fantastic. Unfortunately, again, we did three rounds and a total of 7. So we either tied or I doubt that we won by much. Okay, so we did A, C, E in the first round. And well, let me do it one at a time. That may be too much for me to memorize. So we did A, C, E in the first round, got everything wrong. Second round, we did B, D, E, and E was the only correct one. B, D, E. And the third round, we got B correct. Okay, how did we do? Okay, yes, as I kind of sort of anticipated that we would tie, but a tie is a win nonetheless. Well, if anybody has any idea if we could have done it in only 3 rounds, what sort of ordering should we have picked the criteria cards? Or are there additional sort of conclusions that we could have drawn? Like I said, if we knew it was descending, then criteria card C would be irrelevant. If we have any more of those, that would help out. And if you don't want to miss out on any future videos, please do hit subscribe to be notified. Well, until next time, have a great one.